For over a century, the smartest minds on Earth have basically told you that at its foundational level, the universe is just this random, unpredictable casino.
Yeah, a blurry game of chance, really. It's been the dominant paradigm for a long time.
Right. I mean, you learn classical physics in high school, gravity, motion, action, and reaction.
Predictable stuff.
Exactly. You learn that if you throw a baseball, you can use a clean, precise mathematical equation to predict exactly where it will land.
Right, the math just works.
Well, then you get to quantum mechanics. And suddenly, all that pristine mathematical machinery just totally breaks down.
It completely falls apart.
You're told that particles don't really exist in a set state until you actually look at them. You're dealing with cats and boxes that are simultaneously dead and alive.
Spooky action at a distance, as Einstein called it.
Yes, spooky action. For 100 years, quantum physics has just been this murky, paradoxical, diagnostic headache.
And we've basically just been forced to accept it, to accept that reality is fundamentally probabilistic.
But what if they were utterly mathematically wrong?
Well, that's the big question today.
What if that entire century of quantum weirdness was just an illusion? Like an illusion created by looking at a three-dimensional universe through a two-dimensional lens.
It's a wild thought.
It is wild. And that is our mission for today. Welcome to the deep dive, everyone. Today, we are unpacking a profoundly provocative paper from 2026 by George James Dukas.
It's called The Misconception of Quantum Physics and the Failure of Unification.
And this paper, it doesn't just critique modern physics, it takes an absolute sledgehammer to its foundational pillars.
It really is a massive disruption. Dukas is essentially arguing that reality isn't a casino at all.
Right, no dice rolls.
None. He claims the universe is an exact, deterministic geometric projection, and the blueprint of that geometry is based entirely on the golden ratio.
The golden ratio, which is just mind-blowing. And, the stakes for this deep dive are incredibly high because we are examining an explosive claim Dukas makes about a recent, highly celebrated paper out of MIT.
A little context for you listening at home. MIT recently claimed they had finally done it. They had unified physics.
They built what they called a density bridge.
Right, a density bridge to stitch together the predictable classical world and the weird probabilistic quantum world.
And people were hailing it as a massive breakthrough.
Oh, absolutely. But Dukas steps in and says, not only is MIT's bridge fundamentally broken, but the entire quest for that kind of unification is structurally impossible.
And he offers an alternative, right? This framework called the Transdimensional Unified Field Theory, or TDUFT.
Which is where things get really fascinating.
Yeah.
Because if Dukas is right, quantum mechanics, at least the way we've taught it, isn't mysterious at all.
It's just an incomplete mathematical shadow.
Exactly.
Yeah.
We're going to unpack how the universe actually builds itself today, from gravity to mass.
Okay, so to set the tone here, if standard quantum mechanics is like trying to describe a 3D movie while only wearing, say, the red lens of those old 3D glasses.
Okay, I like that analogy.
Then MIT tried to fix the problem by just polishing that one red lens, right? Saying, look, a clearer picture.
Right.
But TDUFT, Dukas' theory, basically says, no, you need to put the entire pair of glasses on to actually see the depth.
That's a really good starting analogy, yeah. But it goes even deeper than just seeing clearly. I mean, MIT did some incredible mathematical heavy lifting to polish that single lens.
Oh, for sure.
But they are still only analyzing a flat projection. Their math is structurally incompatible with the full three-dimensional reality.
So let's unpack that. Let's start with part one here. Before we totally tear down MIT's bridge, we really need to understand how it was built.
Right. Why were physicists so excited about it in the first place?
Exactly. What exactly did MIT attempt to do with this density bridge program?
Well, to understand the bridge, we have to look at the two radically different islands they were trying to connect.
Okay.
On one side, you have classical mechanics, the predictable world. In advanced physics, this is mathematically represented by something called the Hamilton-Jacobi equations.
Okay, stop right there for a second. Hamilton-Jacobi. For someone who hasn't taken a physics class in 10 years, what does that actually do in the real world?
It deals with classical action and paths. Think of it as the ultimate ledger for macroscopic energy and motion.
Like big stuff moving around.
Right. If you launch a rocket to Mars, Hamilton-Jacobi frameworks help you calculate the exact optimal deterministic path it will take through gravitational fields over time.
So it's continuous. It's certain. Hamilton-Jacobi is the math of certainty.
Correct. It tells you exactly where the rocket will be. Now, on the other island, you have the Schrödinger equation,
The famous one.
the absolute bedrock of quantum mechanics. But instead of dealing with certain paths, it deals with a quantum wave function.
Which is denoted by that Greek letter, right? Psi.
Psi. And psi is an equation full of complex imaginary numbers that represent a wave of probabilities.
The math of maybe.
Exactly. It doesn't tell you where the rocket is. It tells you the percentage chance the rocket is anywhere in the solar system.
So MIT's goal for unification was to basically prove that these two islands are actually the same landmass.
That's it. They wanted to show that you could rewrite the probabilistic Schrödinger equation entirely as a deterministic, classical Hamilton-Jacobi system.
Which sounds like the Holy Grail. I mean, you'd take the weirdness out of quantum mechanics by translating it into classical certainty.
It would have been amazing.
How did they actually try to pull that off, though?
Their method was to introduce a new mathematical variable into the classical side. They claimed that the Schrödinger equation equals the Hamilton-Jacobi equation plus a classical density field.
And they called this field rho of x and t, right?
Yes, rho of x and t, rho meaning density, x for space, and t for time.
So spatial density over time.
Exactly. So MIT essentially attempted to redefine that weird quantum wave function symbol, psi.
They tried to give it a physical meaning.
Right. They said, hey, psi isn't a magical probability ghost. Psi is actually equal to the square root of this classical spatial density.
Multiplied by some exponential term related to classical action, according to the paper.
Exactly.
Wait. So they tried to turn the quantum probability wave into a physical classical fluid, like an actual substance with spatial density.
That is precisely what they attempted. They wanted to treat the quantum landscape like a fluid dynamic system.
I mean, I can totally see why people loved it. It's conceptually brilliant.
It is very elegant.
You're taking this abstract, spooky probability cloud and replacing it with something we can all visualize, a fluid sloshing around in space.
Right. It feels intuitive.
Yeah.
But Dukas looks at this mathematically elegant bridge and says it is completely physically flawed.
Why? Where does the bridge actually collapse?
The collapse happens when you look at the structural materials MIT used to build it. Dukas points out that MIT relies entirely on a spatial, fluid-like classical density.
Okay.
They're treating density like water filling up a bathtub. But even though they slapped a new density label onto psi, the mathematical nature of psi in their equation hasn't actually changed.
What do you mean?
Their new psi remains a complex, unitless, imaginary symbol. It has no actual physical geometry.
So they called it a fluid, but mathematically it's still just a ledger?
Yes, it's a bookkeeping device. And a ledger can tell you the probability of finding a particle, or even describe the density of a theoretical fluid, but a ledger cannot generate physical dimensions.
Right.
It cannot build mass, and it cannot curve space-time to create gravity.
Okay, wait, I want to make sure I'm visualizing this correctly. So MIT is treating density like water, a spatial fluid.
Right.
But if I'm understanding Dukas' critique in the source text, trying to build the physical universe out of spatial fluid is like trying to build a skyscraper out of soup.
Out of soup. Yes, exactly.
You can have all the soup in the world, but it lacks the internal scaffolding to stack upwards, to create structure, to hold anything together.
That is a perfect way to understand it. You cannot stack soup. And that scaffolding, the absolute bedrock structure that MIT is completely oblivious to, is what Dukas calls the dual wave architecture.
Ah, okay. The dual wave architecture.
MIT is trying to build the universe with one imaginary symbol. Dukas proves you need two real physical waves.
Well, let's really dig into this then. This dual wave architecture seems to be the engine driving Dukas' entire transdimensional unified field theory.
It is the core of it, yes.
What are these two real waves, and how do they replace the soup?
Okay, so in TDUFT, reality is not built from imaginary numbers or probability ledgers. It requires two real mechanical physical waves.
Okay.
The first is the expansive wave. Dukas calls this the phi wave, referring to the golden ratio, phi.
The golden ratio, 1.618, the math behind nautilus shells and sunflower seeds.
The very same. But here it is the foundational geometry of space itself. The phi wave is responsible for the lattice growth mode of the universe.
Growth mode, so it builds outward.
Yes. In terms of geometry, it is additive. It pushes outward. It builds out curvature. It is the scaffolding that scales the universe up and out.
So the phi wave is the expansion, the scaffolding pushing outwards.
Correct. Yeah. But think about it. A universe that only expands outward endlessly would just fly apart into nothingness.
Right. It would just dissipate.
Exactly. You need a counterforce. And that is the second wave, the contractive wave. And this is where Dukas completely redefines the concept of psi.
Wait, psi, the same symbol from Schrödinger and MIT.
The exact same symbol, but an entirely different physical reality.
How so?
Well, in standard quantum mechanics and in MIT's failed bridge, psi is an imaginary probability amplitude.
A ghost.
Right. But in TDUFT, Ci is a real physical contractive wave. It creates inward curvature. And most importantly, it is responsible for what quantum physicists call collapse.
Okay, I have to stop you there, because the concept of collapse in quantum mechanics is the thing that usually just melts people's brains.
It is notoriously confusing.
Right. The old Schrödinger's cat idea is that a particle is everywhere at once in superposition until a conscious observer actually looks at it.
The measurement problem.
Yeah, and the act of looking causes the probability wave function to collapse into a single set physical reality, which honestly has always sounded a bit like magic to me.
Because it is basically magic in the standard model.
Yeah.
But Dukas is saying that collapse isn't a measurement trick at all.
So he removes the observer?
He entirely removes the observer from the equation. Collapse isn't some mystical event triggered by a scientist looking at a dial or human consciousness.
Wow, okay, so what is it?
Collapse is a real, continuous physical dimensional reduction, and it's caused by the psi wave.
Break that down for me, a dimensional reduction.
Think of it as a mechanical struggle. The phi wave pushes out, trying to expand geometry to infinity.
Okay.
The psi wave pulls in, contracts, and forces that expanding geometry to fold back in on itself, collapsing it into a stable physical node.
A particle.
Exactly, a particle. It's a mechanical, geometric process, not a probabilistic one.
So if the universe is like a breathing organism, TDUFT says it needs both the inhale contraction, the psi wave, and the exhale, the expansion, the phi wave.
You have to have both to create structure.
And you mentioned earlier that this interaction creates domains.
Yes, the interaction between these two waves creates the two fundamental domains of reality.
Let's go through those.
First, you have the geometry domain. This is mathematically additive phi plus psi. This domain produces the dimensional shells, the curvature tiers, the actual lattice structure of the universe.
And the bones of reality.
The bones, exactly. And then you have the wave domain. This is multiplicative phi multiplied by psi.
Okay, and what does the wave domain do?
This domain produces torsion, interference, the physical collapse we just discussed, and the actual emergence of physical dimensions.
Okay, so if reality requires the inhale and the exhale to function, what does that actually mean for MIT's equation?
It means MIT is trying to describe the entire cardiovascular system by only looking at a math equation of an exhale.
Oh, man.
They completely omit the phi wave. They don't have an expansive geometric framework in their model at all.
So they're missing half the engine.
And they profoundly misunderstand the other half. They treat the psi wave as an imaginary ledger instead of a real contractive force.
No wonder it collapses under scrutiny. I mean, you can't unify classical geometry and quantum dynamics if you refuse to acknowledge that half of the engine even exists.
You absolutely cannot. And this leads directly to the core of Dukas's critique regarding density.
Right, the density debate.
Because MIT thought they did have the missing piece. They really thought their spatial fluid density was the glue that held the classical and quantum worlds together.
But Dukas proves they brought the wrong kind of glue to the construction site.
Exactly. Let's really look at what spatial density is.
Yeah, let's talk about that density debate, because this is where the paper really upends how we think about space and time. MIT used spatial density. Why is that mathematically fatal?
Well, spatial density, denoted as rho of x and t, describes how much stuff is located within a given volume of space at a specific time.
Right, stuff like fluid, mass, energy, like how many people are packed into a subway car.
Exactly. But here is the fatal flaw. Spatial density is non-dimensional.
Wait, what does non-dimensional mean in this context? I mean, a subway car has dimensions. It's a 3D box.
Well, the box has dimensions. But the density equation itself merely describes the behavior of the stuff inside the pre-existing box.
Oh.
It doesn't tell you how the subway car was built. It cannot explain how a dimension is created in the first place.
So it's just counting the contents.
Right. Therefore, spatial density cannot explain how mass actually emerges from a vacuum or how gravity physically curves space-time.
Because it assumes the space is already there.
Exactly. MIT is using an equation that assumes the 3D box already exists to try and explain the origin of the 3D box.
Oh, wow. It's totally circular logic. If your grand unified theory is supposed to explain the foundational architecture of the universe, you can't just assume the building already exists.
You have to explain the bricks.
Yeah, you have to explain the bricks. So if spatial density is just counting people in a subway car, What does Dukas replace it with to explain the car itself?
He introduces a paradigm-shifting concept called temporal density.
Temporal density, time density.
Yes, denoted mathematically as rho sub t, which equals time squared.
Time squared, okay.
Dukas argues that quantum behavior, dimensional emergence, mass, and gravity are not driven by a spatial fluid at all.
Then what are they driven by?
They're driven by the packing or compression of time itself.
Hold on, temporal density. I really need to push back here because this sounds like hardcore science fiction.
It definitely sounds strange at first.
Are we really saying time can be dense like a crowded room? Time is just the ticking of a clock, right?
Yeah.
1 second per second.
That's how we experience it, yeah.
If I swing a rock on a string, the math governing that rock isn't based on the space the rock occupies, but how thick time is around it. How can time bunch up?
It's incredibly counterintuitive because our brains naturally evolved to perceive time as a flat, uniform background progression, like a metronome that never changes pace.
Right, it just ticks forward.
But imagine time is a river.
Okay, I'm picturing a river.
Where the river flows wide and perfectly smoothly, you have empty space. The flow of time is uniform.
Makes sense.
But what happens when that river hits a narrow gorge or a series of rocks?
The water bunches up, it gets turbulent.
Exactly. Creates eddies and whirlpools, get thicker, and exerts more localized force. In TDUFT, time acts similarly.
Oh, wow.
It is an active, compressible operator. When temporal density increases, when time bunches up on the phi lattice, that compression generates physical reality.
So bunched up time literally creates stuff.
Yes. In Dukas's mathematics, temporal density produces mass emergence.
How does that math work?
The actual equation for mass in this framework is dimension cubed multiplied by time squared. Mass is literally a manifestation of dense time.
That is wild.
And gravity is derived as time to the power of -4. The collapse wave, CI, which we talked about earlier.
The inhale.
Right, the inhale. That is driven by time to the power of -3.
This is wild. So an electron, or a planet, isn't just a chunk of stuff sitting in space. It is a localized knot of compressed time.
Mass is emergent geometry driven by temporal density. And MIT's bridge misses all of these dimensional operators entirely.
Because they are stuck staring at the empty space, ignoring the river of time flowing through it.
Exactly.
But, how do we know this isn't just more mathematical parlor tricks? How does Dukas prove that time squared actually dictates physical reality?
He proves it by applying this concept to the most classical, rigidly observed systems we have in the macroscopic world. Planetary orbits.
You mean like Earth orbiting the sun? We've understood that since Kepler and Newton.
We've understood how to measure it, yes. Historically, Kepler's laws and Newton's laws describe orbits using the radius, the spatial distance between the planet and the star.
Right, the distance.
It's a purely spatial relationship.
Hmm.
But Dukas walks through an astounding derivation in the paper. He takes the original geometric law of orbital periods and reformulates it entirely into a pure density law.
He strips out the space.
He calls it the Dukas density orbit law.
Okay, lay the math on me, but let's take it slow.
It's surprisingly elegant. He proves that the period of an orbit squared multiplied by the temporal density is equal to phi cubed, multiplied by the phi lattice density.
Wait. There is no spatial radius in that equation.
None. The spatial radius cancels out entirely.
So what's actually left?
What remains is a direct equilibrium between the density of time and the structural density of the golden ratio lattice.
So the golden ratio is literally dictating planetary orbits through the density of time.
Yes. Even classical orbital mechanics, the majestic, predictable clockwork of our solar system, the very thing Hamilton-Jacobi was designed to describe, is governed by phi lattice density and temporal density.
Not a spatial fluid.
Not a spatial fluid.
That is a massive blow to MIT's model. I mean, MIT tried to use spatial fluid to bridge the classical and quantum worlds, assuming classical physics relied on spatial density.
And they were wrong.
Dukas just proved that even the planets aren't governed by spatial fluid. MIT built a bridge out of a material that doesn't even exist in the classical world they were trying to connect to.
Precisely. They applied a non-dimensional spatial construct to a reality that is fundamentally temporal and geometric.
You just can't do that.
You simply cannot unify gravity and mass using a spatial fluid because gravity and mass are products of temporal density.
Okay, so if MIT's bridge is structurally broken and standard quantum mechanics is blind to the whole picture, what does the real bridge look like?
This is where we get to the core of TDUFT.
Right, let's get into it. Part 4 here. The paper introduces this ultimate framework, the universal master unification equation, which Dukas apparently calls Maximus.
Maximus. It commands respect, doesn't
It
it?
sounds like a gladiator.
Yeah.
But I guess if it unifies physics, it earns the title. What does Maximus actually do?
Well, when you restore the dual waves phi and psi and you restore temporal density,
Oh.
MIT's bridge doesn't just get fixed, it transforms entirely.
Into what?
It becomes this single covariant operator on the eternal lattice. Maximus is the mathematical heart of the universe.
I'm looking at the equation in the source notes right now, and I'll be honest, it is incredibly intimidating.
It's dense math.
Yeah, it's got partial derivatives, delta symbols, upside-down triangles, natural logarithms of phi. Can you translate Maximus into something I can visualize?
Absolutely.
Without reading me raw calculus, what are the two sides of this equation actually doing to the universe?
We can absolutely translate it into physical actions. Think of Maximus as an equation of ultimate balance, a tug-of-war.
Okay, a tug of war.
The left side of the equation describes the expansive induction current. This is the outward push of the universe.
The exhale of the phi wave.
Exactly. The outward geometric scaffolding. Now, what's crucial for our MIT discussion is that this left side is the only part that MIT's Hamilton-Jacobi term captured.
So MIT only got half the equation.
Yes, MIT successfully mapped the expansive geometric projection, but they stopped there. They thought that was the whole universe.
Because they missed the inhale. They missed the other side of the tug of war. So what is the math doing on the right side?
The right side is the entropy gradient term. In the math, it acts like a gravitational drain. It is driven by the negative natural logarithm of the golden ratio, which pulls energy inward. This side of the equation is the engine of contraction.
The psi wave in action.
Yes, this right side drives the collapse of the wave function into physical particles.
It literally makes stuff physical.
Right, and it drives time asymmetry, which is the reason a dropped teacup shatters but never spontaneously reassembles itself.
It creates the forward arrow of time.
Exactly. And it also drives dimensional tiering, which dictates how the universe scales up from tiny subatomic scales to microscopic galaxies.
Wow. So MIT mapped the outward push, the expansion, but totally missed the inward pull, the entropy and collapse.
They missed the drain.
But what really stops me in my tracks here is the presence of phi, the golden ratio, 1.618.
It is everywhere in this theory.
This is a number I learned about in art class, Studying Leonardo da Vinci, are we really saying that an aesthetic proportion dictates fundamental physics?
It is much more than an aesthetic proportion. Phi is the only mathematical ratio that is inherently self-referential and scale invariant.
Meaning what?
It perfectly relates the part to the whole. No matter how much you zoom in or out, the ratio remains stable. In Maximus, phi leg acts as the single covariant operator on the lattice,
Okay.
and the results of this are staggering. From this one equation governed by the golden ratio and the second law of thermodynamics, Dukas derives everything.
Define everything.
The paper states that Maximus derives all 25 fundamental particles in the Standard Model.
Wait, all of them?
All of them. It derives their exact masses. It derives the precise absolute value of the speed of light, c, purely through golden ratio harmonic convergence.
Wait, I need to challenge that. In standard physics, we don't mathematically derive the mass of an electron, right?
No, we don't.
We just measure it in a particle accelerator, write the number down, and plug it into our equation.
That is correct. Standard physics is littered with what we call free parameters.
Free parameters.
There are dozens of arbitrary numbers, like the mass of an electron or the strength of electromagnetism, that our equations simply can't explain.
We just have to accept them because experiments gave them to us.
Right. If you ask a standard physicist why an electron weighs what it does, the answer is essentially because it does.
But Dukas doesn't use free parameters.
Not a single one. TDUFT derives them from first principles using the phi lattice.
That is nuts.
It calculates gravity as temporal inversion. It even derives the fine structure constant plane.
The 1/137 number.
Yes. That notoriously mysterious number, roughly 1/137, that dictates how light interacts with matter. Dukas derives it entirely from phi powers and the attenuation of the lattice.
That is profound. It means the universe isn't arbitrary at all.
Not in the slightest.
It isn't just throwing dice in the dark and randomly ending up with an electron. It is a perfectly tuned, logically unavoidable geometric instrument.
It is the signature of a universe that is a self-referential harmonic projection.
And MIT, with their density bridge, just mapped half the instrument. They map the soundboard but completely miss the strings.
Which brings us to what I consider the most devastating critique in the entire paper.
Let's get into it. Part 5.
Because Dukas doesn't just say MIT's bridge is incomplete. He provides a mathematical proof for why standard quantum mechanics, as a whole, is physically trapped in an illusion.
You don't just overturn a century of established quantum mechanics without hard receipts.
No, you need proof.
So what is this foundational error that has kept thousands of brilliant physicists basically stuck in the mud?
The error lies within the Schrödinger equation itself.
The bedrock of quantum physics.
Yes. For 100 years, we have believed that the Schrödinger equation describes fundamental physical reality in 3 dimensions.
Right.
Dukas reveals that it absolutely does not. It is fundamentally what he calls a domain trap.
A domain trap. Okay, break that down for me. What is a domain?
In Dukas's geometric framework, reality is built of dimensional tiers. Think of them as layers of reality.
Okay, layer.
You have D1, which is linear, D2, which is a flat surface, D3, which is volumetric space, the 3D world we physically occupy and move around in, D4, which incorporates force.
Okay, 1D line, 2D flat, 3D volume, 4D force. Makes total sense.
Now, look at the mathematics of the Schrödinger equation. At its core, it relies on a specific mathematical tool called the Laplacian operator.
Okay, the Laplacian operator.
Dukas demonstrates that this Laplacian operator is strictly confined to a 2D surface, what he calls the D2 charged surface domain.
So Schrödinger's equation mathematically only exists in 2D, like a flat sheet of paper.
Exactly. It is a 2-dimensional mathematical shadow. It is merely a collision-counting artifact.
A collision-counting artifact, meaning it just tracks bumps on a flat surface.
Yes, it functions as a ledger of elastic interactions happening on a flat 2D surface.
Okay.
But it is cast by the true, higher-dimensional 3D and 4D philatus.
Hold on, I have to play devil's advocate here.
Please do.
If the Schrödinger equation is just a 2D illusion, why has it been so wildly successful? I mean, we built lasers, MRI machines, and microchips using quantum mechanics. The whole modern world runs on this math.
It works spectacularly well within its narrow, specific domain.
So it's not wrong, it's just limited.
The phenomena you just mentioned, like the photon propagation or electrons jumping between atomic energy levels, operate essentially as surface phenomena at that quantum level.
Oh, they are 2D events.
They are D2 interactions,
Yeah.
so the 2D math of Schrödinger perfectly maps them.
Okay, I see.
But the moment you try to use that exact same 2D math to describe D3 volumetric mass or D4 force or macroscopic gravity, it catastrophically fails.
Because you can't describe a 3D apple using only the 2D shadow it casts on the table.
Precisely.
Yeah.
And the paper provides an explicit mathematical proof of this domain trap. It extracts a closed-form solution from the equations governing the speed of light.
Okay, what's the proof?
The proof is simple but absolutely lethal. The equation is d squared equals d cubed times the absolute value of psi.
Let me visualize that. D squared, meaning the 2D domain, equals D cubed, the 3D domain, multiplied by the absolute value of the psi wave function.
Yes.
How does that prove a trap?
Because of the absolute value barrier acting on a non-dimensional ledger. This single line of algebra explicitly proves that the standard quantum equation is mathematically locked to a 2D surface.
Locked to it.
The dimensional tiers cannot cross that absolute value barrier without losing their spatial volume. You literally, algebraically, cannot reach volumetric mass, D3, using an equation bound by that relationship.
It is structurally impossible.
Structurally impossible.
This is really starting to make sense. It's like trying to program physics for a sprawling, photorealistic 3D virtual reality game, but you're stubbornly forcing yourself to only write the code using the original 1980 rules of Pac-Man.
That is a brilliant analogy. Let's explore that.
Right, because Pac-Man is perfectly accurate within its own domain.
Yes, the flat maze.
In its flat 2D maze, the math works flawlessly. You know exactly where the ghosts are, you know the collision mechanics.
It perfectly maps D2.
But that 2D Pac-Man code fundamentally, structurally, cannot tell you how to build a 3D mountain. It can't simulate a gravitational orbit in 3D space.
It simply lacks the operators.
Right. So unification isn't about figuring out how to add a new quantum ghost into the Pac-Man maze. Unification requires abandoning Pac-Man and building a completely new 3D game engine altogether.
That is exactly what Dukas is arguing. And this is the fatal dagger for MIT.
Oh, because of the density variable.
Because MIT took their classical spatial density variable, which is 3D, and they bolted it onto this 2D confined Schrödinger equation.
They attached it to Pac-Man.
Consequently, their density term immediately inherited the exact same 2D limitation.
They bolted a 3D fluid onto a 2D shadow.
Yes. You cannot unify macroscopic gravity and physical mass using 2D surface math. It doesn't matter how clever your algebraic bridge is.
Right. If the foundation is 2D, the whole bridge is 2D.
Exactly. If one side of the bridge is anchored in a two-dimensional illusion, you can never cross over into a three-dimensional physical reality. Schrödinger is the boundary that prevents unification.
Wow. Schrödinger is the boundary. That is just a paradigm-shattering claim to make against the titans of 20th century physics.
It's a complete rewrite of the rulebook.
But, as we all know, physics is an empirical science. It requires proof. You can have the most beautiful, philosophically satisfying, mathematically elegant theory in the world, but if it doesn't match the data in the laboratory, it's just poetry.
Very true.
So what is the physical evidence that actually supports TDUFT over standard models? Does this geometric lattice really exist?
Dukas doesn't just rely on math. He points to several major physical experiments, some historical and some very recent, where standard physics saw anomalies or unexplained noise, but TDUFT sees absolute predicted confirmation.
Okay, let's go through these. Part 6, the empirical evidence.
Let's start with the historical one. The Brill et al. Anomaly from 1979.
1979, Brillet and Hall. Okay, what were they trying to do?
They were designing an incredibly precise laser experiment to test the isotropy of the speed of light.
Isotropy, meaning it's the same everywhere.
Exactly. Essentially, they wanted to prove that light travels at exactly the same speed in every single direction, no matter which way you point the laser.
Which is a huge part of relativity.
It is a core, fundamental tenet of Einstein's special relativity. And standard physics textbooks will tell you that Brillet and Hall successfully proved it.
But I'm guessing they actually found something else.
They found a tiny, persistent variation in the speed of light, a microscopic anisotropy on the order of 10 to the power of negative 15.
10 to the negative 15.
And crucially, it had a very clear 2 omega harmonic dependence as their apparatus rotated in space.
Wait, 10 to the negative 15, that is unimaginably small. Most people, even physicists, would just call that a rounding error, right?
Absolutely.
Like a slight vibration in the room, static on the line.
And that is exactly what the mainstream physics community did. They labeled it noise. A null result. They swept it under the rug because it conflicted with relativity.
Wow.
But Dukas runs the TDUFT equations and shows that his theory predicts exactly this variation.
How does a geometric lattice predict a tiny fluctuation in the speed of light?
Because in TDUFT, the Earth isn't just a dead rock floating in an empty void. The Earth is a rotating psi to the power of 4 planetary contraction node.
Whoa, hold on. A contraction node. You just turned the planet Earth into a math equation again.
Well, it is math.
What does that actually mean if I'm standing on the surface? I don't feel like a contraction node. I just feel gravity pulling me down.
Gravity pulling you down is the contraction node. Remember temporal density.
The bunched up time.
Right. Earth is a massive concentration of bunched up time and inward pulling psi waves. It acts as a massive anchor on the universal lattice.
Okay.
As the Earth rotates, it literally drags and subtly perturbs the local geometric lattice around it.
It pulls the fabric of space.
Dukas provides the full derivation, showing that this specific Earth-scale perturbation, dragging the lattice, produces the exact amplitude and the exact 2 omega harmonic signature that Brillet and Hall observed in 1979.
You're telling me Brillet and Hall literally measured the friction of the Earth dragging the fabric of the universe, and we ignored it because it was too small.
It wasn't noise at all. It was the physical signature of the structured Phi lattice interacting with planetary mass.
That is just mind-blowing. What about the Kennedy-Thorndike experiment? The source material brings that one up as well, and that's a big one.
Yes, very famous.
Because in my high school physics class, I was taught that the Kennedy-Thorndike experiment famously disproved the existence of the ether.
The old 19th century ether.
Right, the idea that space is filled with the physical, invisible medium that light travels through. Didn't that experiment kill the ether forever?
It killed a specific type of ether. The standard model states it disproved a rigid, static, classical ether.
Static meaning it doesn't move.
An ether that just sits there like an immovable block of ice while planets swim through it. And they are right. A rigid ether mathematically and physically doesn't exist.
But TDUFT doesn't propose a rigid ether.
No, TDUFT doesn't propose a rigid ether.
Right, TDUFT proposes the phi lattice. How is that different?
The TDUFT phi lattice is a dynamic fractal network.
Yeah.
It is not static. It is dynamically stabilized and co-moving with local temporal density fields.
So it moves with the planets.
The planetary node, the Earth anchors and lines the local lattice around it. Dugas argues that the Kennedy-Thorndike null result perfectly matches TDUFT because the local temporal density field actively compensates for the directional variations they were trying to measure.
So the standard model threw the baby out with the bathwater. They proved a static, rigid ether was false and arrogantly assumed that all structured mediums in space were false.
They didn't conceive of a flexible, dynamically anchored ether.
Because they lacked temporal density?
Exactly. They lacked the concept of temporal density, so they couldn't imagine a medium that adjusts to mass.
That makes so much sense.
And if you want more recent, undeniable proof that the vacuum of space is not empty, Dukas points to the Technion bright-squeezed vacuum experiments.
Bright-squeezed vacuum. BSV.
This sounds incredibly modern. What happened at Technion? Researchers at the Technion Israel Institute of Technology recently performed an experiment where they fired incredibly short laser pulses into a pure vacuum.
Completely empty space.
Completely empty space. And they produced massive trillion photon pulses from a vacuum state that had a measured zero average electric field.
Wait, they got a trillion photons, a massive flash of light out of essentially nothing, out of empty space.
Out of a vacuum, yes. And it happened in a time scale of exactly 27 femtoseconds.
That's incredibly fast.
Now, standard quantum mechanics, and certainly MIT's density bridge, cannot explain how an inert vacuum can suddenly become so violently active and produce a trillion photons.
Because in their model, the vacuum is just an empty 3D box. There's nothing in there to make photons out of.
Exactly. But TDUFT predicts this perfectly. In TDUFT, the vacuum isn't empty space. The vacuum is what Dukas calls a D10 vacuum magnetism.
D10.
It is a highly compressed, energetic state of the lattice. When the laser pulses hit it, it triggers a dimensional torsion transition on the lattice from D2 to D3.
So the laser forces the lattice to pop a dimension.
Yes. And the timescale for that specific transition, calculated purely by TDUFT math, is exactly 27 femtoseconds.
The exact time measured in the lab.
Exactly.
So the physics community has been looking at their own incredibly expensive experimental data, seeing these tiny anomalies in the 70s or these unexpected massive bursts of photons today, and basically just sweeping them under the rug as static or unexplained quantum weirdness.
They just don't have the framework for it.
But Dukas is pointing directly at the data and saying, that's not static on your radio. That's the actual broadcast of the universe's architecture.
He is showing that the signature of the golden ratio lattice has been hiding in plain sight in our own data for decades. We just didn't have the right mathematical glasses to see it.
Okay, wow. Let's step back and summarize this massive journey for everyone listening, because we have covered an incredible amount of dense ground today.
A lot to take in.
We started with MIT. MIT built this mathematically elegant, highly praised density bridge to try and unify classical deterministic physics and quantum probabilistic physics. They claimed that Schrödinger equals Hamilton-Jacobi plus a classical spatial density.
And we learned structurally why this bridge is doomed to collapse.
Right. They tried to patch a 2D shadow. They used spatial fluid, the soup, instead of temporal density, the compression of time.
They missed the boat on density.
They treated the psi wave as an imaginary math ledger instead of a real contractive physical force pushing inward. And they completely ignored the existence of the phi wave, the golden ratio expansion that builds the structural geometry of the entire universe.
The ultimate takeaway here is that real unification isn't just a clever algebraic hybrid of classical and quantum math.
It's not just mashing equations together.
No, it is the profound realization that both classical physics and quantum physics are just different, limited projections of a single, infinite, self-referential phi lattice. Reality is driven by expansive outward geometry and contractive inward temporal density.
It fundamentally changes everything about how we view the foundation of reality.
It truly does. If you, the listener, take anything away from this deep dive, let it be this massive shift in perspective. Quantum mechanics was never weird.
It wasn't spooky.
Einstein famously said he didn't believe God plays dice with the universe. Dukas is mathematically proving Einstein right. There are no dice.
No random chance.
The apparent randomness, the weird superposition, the measurement problem, it was all just an artifact of an incomplete map. The universe is a perfectly tuned, geometrically deterministic structure governed by the golden ratio.
And that brings us to the final thought. We've spent this time talking about abstract particles, mathematical derivations, planetary orbits, and the speed of light.
Good picture stuff.
But I want to leave you, the listener, with a question that brings this cosmic architecture right down to a human level.
Ooh, I like where this is going.
If every particle, every mass, and the very flow of time itself is just a harmonic resonance on this infinite, geometrically perfect full lattice, then what does that mean for you?
A physical manifestation of the lattice?
Right. You aren't just a random collection of chemical probabilities wandering around in a detached, empty universe.
You are part of it.
Your very physical structure, every single atom in your body, every pulse of your brain, is an active, geometric knot tied directly into this eternal breathing lattice. You are the universe mathematically projecting itself.
You are a direct physical resonance of phi.
If reality is a perfectly deterministic, self-referential, harmonic projection, if it's all an intricate mathematical hologram, then who or what is doing the projecting?
It seems that broken quantum machinery we were complaining about at the very beginning wasn't broken at all. We just didn't realize we were staring at the gears of a much grander clock.
Something for you to chew on until our next deep dive.